Welcome to In 5 Minutes. After understanding ports, I/O and other things, there are two things left. Let's try to differentiate between the polling method and the interruption method. Both methods goes hand to hand. In earlier video we already said that polling in some cases is better, interruption in some cases indeed better. In this video we'll be discussing in detail how exactly they work. Starting with the first one, we'll be talking about polling technique, how polling works in detail. Okay, let's say our application needs some data. This request would be granted to the CPU. CPU would accept the request and will go forward for checking status of the device from where it is supposed to read the data. It will then go to the status register and it will check whether it is idle or not. If it is idle, well and good. In this scenario, CPU will go to the next stage, will issue command for device controller. By saying this, it would put a command in the command register which will eventually get executed and read the data. Once the command gets executed by the device controller and data is made available, data would be given in a data in register as we have already discussed, and from data in register again CPU reads down this data and copy it to process address space which initially needed the data. Now, major drawback of this technique is through step 2 to last step, continuous need of CPU would be observed, making CPU utilization very high. And during this phase, right from the making request to getting the final data in, CPU will be used and continuously waiting for the result. This causes even the battery usage, if we are talking about some mobile devices, to minimum. Very extensive use of a CPU would also be seen. Compared to polling, we can also shift to the other technique, which is interruption. In interruption, we have slight different way. In this, when application needs data, it would not communicate with the CPU directly. In fact, the application would directly communicate with the device driver. Device driver would check status register and see whether it is idle or not. If it is idle, well and good, we'll go to the next thing. It will inform device driver to issue command to device controller, which would eventually execute the command and read needed data. When data is read and ready and buffered, only during this time CPU involvement starts. The device driver informs CPU about data to be ready. As an end result, CPU will run needed ISR to the device so that it can give whatever data has been read. Finally, copying the data to register in and finally giving data back to the process which requested it. In this technique, the CPU utilization is greatly limited to the point from where CPU is interrupted and only till the time data is made available by the CPU to the process. So only during this part CPU came into utilization. And another important thing is, in this CPU is never waiting, because CPU only is communicated when everything is ready, and CPU will simply copy and stop its working with reference to this process. So this is better in terms of CPU utilization. In both of the algorithms, we have not mentioned, but it is to be understood that if something went wrong, if the device is not idle, only this, in this case, we would be simply shifting and waiting without any option in hand. Even in this, the same thing would happen. So this is what interruption and polling technique is about. Keeping both next to each other, we have certain outcomes. Polling, it continuously polls I/O for change the value. Okay, good things. Bad things about it, most polls are unneeded and value did not change, so we had to wait and waste our time most of the time. It required very high CPU utilization, that too this utilization CPU most of the time waited doing nothing. Reaction time depends on I/O. That means whenever I/O data is available, how fast it can be read and brought to data in register. As far as interruption is concerned, normal execution is interrupted whenever data is ready. In this scenario, we have one simple thing. Processor resources are only used when necessary. This is a plus point about the entire thing, and this is something which we call as a great option, especially with mobile devices. But again, it has a downfall that from a normal mode, it has to shift to interrupt service routine mode. Because of this, the behavior is non-deterministic. By saying this, we always say performance would go down. Why? How many times CPU will be interrupted and for how much time? This has never been known. Well guys, so that's we have. We have two better techniques to talk on. Polling, in which CPU is continuously involved. Interruption, where CPU is only involved when data is ready, and the comparison. So that ends our video. Thanks for watching.